Hi everyone. Today we'll look at super exciting hands-on exercises. This is really important for you guys. Session management. We're going to work on the Flask. Flask is a fast prototype that you can test the web services. So rather than setting up a web server, mainly because most of us do not have web server installations and configurations, right? It's not really hard, but you guys need to have a Linux box so that we can install it. It's very useful, but suppose it's not available. Well, this is a real work prototyping, the Flask. So you guys already had one session of a Flask. So today we'll look at this super exciting the exercises. Session hijacking, secure cookies, and session monitoring. All right. Session hijacking takes place when an attacker gains unauthorized access. So this could be very common. Once it takes place, its damage is really huge. And the session is created when a web user access a web server. So all the web application has the sessions could be authorized, but that authorized user session may be hijacked by someone else. It's not really the operating system's shell hijacking. This is cookie hijacking. Okay. So I'm going to explain that a little later. Probably in the later slide, explain that. So session token could be theft or less managed carefully. So that is a vulnerable. Typical session hijacking could be a sniffing, but more the modernized hijacking is cross-site scripting. So it injects malicious scripts. The recent days, there's a session token. Session is created for each web user when a user accesses a web server where there is a web application is running. Session fixation. In this attack, attacker sets the session ID for a user and then takes over the session after the user is logged in. Or typically, man-in-the-middle attack is also hijacking. Could be many ways that we can prevent session hijackings. We can use HTTPS rather than HTTP protocols. And also secure session cookie may be installed. That's what we are going to learn today. Okay. So session cookies is automatically generated. So there is a HTTP only flag may be available so that it can prevent JavaScript from accessing the session token in cookies and migrating the risk of cross-site attack. And secure flags ensure cookies are only sent over HTTPS, and that way you can prevent session cookie stolen from being transmitted over insecure channels. Same site attack. This attribute helps prevent cross-site request forgery. So actually, we're going to have an exercise, hands-on exercise about this CSRF token to be used. Another thing is generate session ID. This is also we're going to practice. Regenerate the session ID after a successful login or when moving from a less secure environment to a more secure one. This prevents session fixation attack. It cannot be reused because the session ID can be regenerated. And session explorations and timeouts. We can also set up the expiration period, and also IP address or user agent validations can monitor, validate the user's IP address and the user agent string to detect anomalies and potentially prevent session hijackings. This is another method, and a multi-factor authentication. This is very common, right? And also monitor log session activities. I'm thinking of giving you a homework assignments to do this session activities by understanding and practicing secure session cookies and session regenerations. So all the code can be available. What actually I'm going to give you on this slide as well is a simple, vulnerable coding list. And on this lecture, of course, this is recorded so that you can update your code to do prevent session cookie steals, so that we can set up secure sessions and regenerations. In addition to that, I want you to work on this monitoring and log sessions. This is your homework assignments. So cross-site scripting. So in our sample code that you may be able to see, and then you can see there is a JavaScript code is available. So we'll look at that. Okay, hands-on lab, we're going to work on Flask. And then session data is stored on a server. Session is an interval at which a client will log on to the server and log out the server. So each user, when it log in, then session cookie is generated. And when it access another page, another web page, then could be another session cookie and another session cookies. Session cookie is automatically generated. We're not going to work on how to generate it. It is hexacode automatically generated. It is encrypted, and all the cryptography is involved. this class is not dealing with that, but we are going to see how it works, how it can be vulnerable, and in what way we can strengthen the security levels. That's what we want to do. The data that is required to be saved in the session is stored in a temporary directories on the server. Part of this, I think you need to do on your homework assignments for monitoring. And for example, user maybe fail on the web server, and then we can set up maximum attempts. If it is over, then we need to give some of the error messages, right? Warning messages. So till that time, we need to save, store, and bookkeeping of user access, user activities. Session data is stored at the top of the cookie. The server signs it in encrypted mode. For this encryption, the Flask application required defined so that we have this secret key from that Flask. App is an object of a Flask. An object of a Flask. Then object has this field name. There we can store. Threats on web. Malicious website tricks your browser into sending a hidden post request to mylink.com/transfer. So Flask, we can set up, for example, this web server and then /transfer. This is another page. There we could have, for example, this kind of JavaScript. This JavaScript is really a super dangerous. This is a easier way to attack your information within that web server. What happens here is that this script immediately activated. So it fires silently. It doesn't tell you. Okay. So document means within this the same documents, we can check whether it has some IDs, some of the patterns. So that pattern is automatically submitted. For example, your HTML, there is a form, and then there is a submit function, submit button. Hopefully, you guys know a little bit about HTML. Okay, HTML. Then we can set up the form, and then there's a text field, so you just enter, and then finally on the bottom of that page there's a submit button, and click that. Then all the information will be submitted to the server and do some the corresponding process. So that can be done automatically and silently. So that is a threat on the web that we want to see. Okay, a little bit of those. And then another thing is Flask WTF CSRF protections. This is a web tool form. There is a web tool form, and across the site, I believe this is some of forgery, and then this is all for, I forgot what that is. So let's check here. CSRF. You can get that. Yeah, cross-site request forgery. They need to be protected. When you have a post request. So on your web server, for example, in HTML, the transfer method is, it could be post or get, right? Get or post or put. Those three different requests is possible. Method, right? So we're going to use this. If we use this, then we can, this WTF CSRF can be configured, and it can protect any unauthorized request. How Flask WTF blocks it? This Flask WTF, of course, this is a module. Then on your Python program, you need to import it. It solves this with the secret token that is generated in your server. It's automatically, right? Of course, silently, for the sake of your security. And it is unique per person, must be included in every post request. So you need to first check if it is a post or get or put. Only post request is possible. Cannot be guessed or forged by an attacker. The attacker's site has no way to read the token from your session, so their forged request failed. So you will see that clearly in our demonstrations. Of course, you will get the code. This is a small Flask. Using Flask, you can use Apache, other web servers to set up, but for the fast prototyping, we'll do Flask. So URL can be on your, for example, the IP address. At the end, we have a slash, then that is a home address, /login, /logout, /account, /transfer, and / whatever. It could be a separate pages, right? So on each page, it should be the token, a session token is to be regenerated. That should be in, right? And uses a Flask login to manage a login versus not, and the Flask session to store a per person, per session value. This Flask WTF CSRF. So WTF uses CSRF protection for post forms, and it sets a few security headers. Although it is not really readable, right? It is encrypted, but I'll show it to you. Rotate session states at the login, logout to reduce the session fixation style risk. Lab 1, so baseline. So there is no CSRF protections, okay? Simply, therefore, vulnerable. So login user visits one of those web pages that triggers a non-user intended post. So intentionally we make some, rather than posts, maybe get when you log out. Because the transfer endpoint access accept post with the only cookies for authorizations, the transfer goes through. So a little bit of the coding skills now to be explained so that you may be able to understand when you have the code, right? In Flask, there is @ sign app.route, @ app.get, app.post. App, it could be, it's not really all the time. This is just, it's not a generic name. This is simply a variable object of Flask. So definitely you need to first have app equals Flask, open and close, so that Flask object can be generated, which means the object instantiations, right? So instance of objects of Flask is created, constructed. We call that app. We name it, right? At app, then what is app? Oh, that is an object of a Flask. Because of that this is an object of a Flask, all the properties associated with the Flask class can be accessed by this object. In this case, this is a method, right? .route method, .get, .post. Those are the method already developed here, Flask class. So we simply use it. In this route, then, we want to, this is another web server. Whatever your IP address /contact, that is a web server. The method to access this web server could be get or post. Of course, route allows to get or post. So this is a very, very useful, and this is the right way that you need to do. Like here, and then this is a web page, and then when it goes into that web page, then this is the Python code. This function is activated. When you go into this web page, this function is activated. So it checks whether the method, request method, is post, then we can handle this. Otherwise, some others, right? Similarly, not only this method, another method, get or post, right? Get method into another the web page /about. So this could be, if you say app.get, it is nothing but get only in this route. Post, then post only. Then we simply say app.post, app.get, or app.route. App.route, then both get and post methods are allowed. It has also so few fields in the Flask. The field name is config. It contains some of the configuration data in a dictionary formats, and also secret key. This field has a specific configuration setting. So we can get that from, for example, config secret key or something else. Secrets module needs to be imported in your Python code already in, right? So you simply see it. A built-in Python module designed for generating cryptographical strong random values. So when you do this is a random value based the hexacode generators. So we can use that. There are two types of uh, the methods that we are going to use. If you see token underscore hex and then any number here, say 16, then you can use 16 times 2 the codes. So because this is a hexacode, if you say, hey, I want to use a 16 byte long characters, each byte can be represented in 2 hexacode, right? So that real size of that hexacode would be the number of the bytes that you can get here times 2. So in this case, if you put here 16, then the size of a hexacode is 32. Similarly, if you use a URL safe method, token underscore URL safe, which takes as a parameter a number, say 16, for example, then it can generate here, it encodes 3 bytes into 4 characters. So in this case, 1 byte to 2 characters. So for the 3 bytes, 4 characters. So for 16, then it could be 22 the long the size of that, right? This is for example, if it is a 3 bytes, then 6. But in this case, the 3 bytes, then it goes to 4 characters. 3 bytes goes to 6 characters in this token hex. In the token URL safe, 3 bytes will be 4 characters, a little bit shorter than that, right? So we can start with a small Flask web. So the Flask session to store a per person value. We will use Alice and Bob, and then transfer monies. We can see that there's some fraud points. We can upgrade. So we could have, you will see this code. Code is given. So together, all together, we can upgrade the code based upon this code given, right? So that we will have a secure the code. Okay, this is a code. I'm going to explain this code so that we can see that. So we use many modules: Flask, request, session, redirect, URL for, render template string. Those are the modules from the Flask packages. And another package here, Flask login. We can import the module login manager, user maxin, login user, login required, log out user, current user. Having those modules available on your Python, then first we construct an object of a Flask. So Flask underscore underscore name underscore underscore close, then we will get an object of a Flask. This Flask object can have a secret underscore key. Remember that we have that, right? We can put some of the strings that we want to use, right? First thing that I want to point out here, if you give this hard-coded the secret key, then it is vulnerable, right? So another way that you can do, you can import OS modules, and then there is a environment. So you can do, I think that is, yeah, OS. Instead of this, OS dot environment in and then you can put here some of the file path. So it's not your secret. The phrase is not hard coded here, but it can be stored in another separate file. So whoever reads this code do not know the key, right? The secret key phrase. It is automatically loaded in this Python code. This is not only here in Flask, in any type of languages, even in Python. This is a Python specific language. Yeah, you can include from any separate files which could be stored securely. And then the login manager of that app. This app is a Flask objects, and then we create a login manager object. That object has the field name login view, so we can say login. And also we can create a dictionaries of the users. So Alice password 123, pass 123, Bob pass 123. The initial balance of the bank accounts is Alice 1,000, Bob 1,000. And also we can create a user maximum try, right? Try into that so that username may be stored in this class. And the load user, another function, user ID comes, and that if that user ID is in this user dictionary, then we can say it returns this user. This is a class, right? So the user object is created for that user ID, I would say. Okay, so that user ID's name is whatever is. It could be Alice, could be Bob, it could be John, could be Chris, whatever. That object is created. And also we can think of CSRF protect object constructed. So that is a global CSRF protections. So every post put patch delete request is automatically checked for the valid tokens. Okay, post put. But if we have a get is a little bit vulnerable, right? To every incoming post put patch delete request, then we extract a token from request and compare with the token stored in the sessions, and then we can say allow or reject. So this is CSRF. Protect has a CSRF token. So in Flask TSRF token methods, that is a function available in Jinja 2. It automatically made available when a CSRF protect is initialized. So we can, it generates and secure the current session of CSRF token as a string for the user. So if you want to get that CSRF token in your web server automatically, then you need to, so that is in the form, right? Before you have input, then you have form. I'm talking about HTML, the web page, and then there is input. So we have input and name equal the variable name, right? Equal, let's say, username. Simply like that. And somewhere here, /form. Then on your web page, there is a username. And then text field, right? And some others. And the bottom, it says submit button. You enter here your username and then click, then it goes, right? This is a typical banking system web server. So if you look at this, there is the web page. I believe this is one and second one and third one. Okay. So money bank and user. This is actually a placeholder, like a variables, right? Balance, else equal. This is, I believe this is a JavaScript language, right? So double open curly braces paired with the double close curly braces. So curly brace, space is important here. And then variable and space and a close curly brace and close curly brace. In this way, this is a variables. I think I have a slide that I explained that somewhere. Okay, here. So this is a double curly brace. This is a Jinja 2 syntax, like a JavaScript, for outputting a value into HTML. So on your code, HTML, the Python code, some of the variables can be taken, and then you can send that variable to the HTML page. Then HTML can render on your web browser. Okay, and so you can use this. This is output values. Inside this is a variable name there, right? And then similarly, there is a curly brace %. This is open tag, and there is a closing tag, % and curly brace. Then that is a logic tag. So you can use if statements, conditional statements, or iterative statements, for loop or block. Similarly, if you have a pound sign with a curly brace, then it is a comment. So for example, the curly brace user this is your HTML, right? Hello, and then you want to put some real name, but let's say this is a variable. So this variable is to be fed from your HTML, your Python code. Python, well, more specifically, not just a simple Python, but Flask Python. So that we have here @app.get. So this guy says, hey, if you have the home web page, then whatever that you handle this function, it goes to that home web page. So here it says user equals Alice. This user is nothing but that. So on your web page, it says, hello, Alice. Okay. And then that web page is home.html, which is when you come here, if you say home underscore TMPL, then you can say home underscore TMPL. Instead of this, home underscore TM, home TMPL. Similarly, URL underscore for this kind of a function, right? This function can be also used, not only a variable within that double curly braces. You could have a function within that double curly brace. So let's say on the Python, which goes to /login, you define a function login. This is a function. Then on your HTML, you can do URL for and that login function can be here. For example, here, home, and then I sent HTML underscore TMPL, and then user equals user, balance Alice equals BAL, balance, this is a dictionary, right? BAL, dictionary with the key Alice, and then balance of a Bob, then dictionary bell for the key Bob. This goes to render template string. This is a function. Remember that we imported that, right? We already imported that once here. This is imported from Flask. So that's going to be, yeah, this is a render template string in Flask. So what it does is a render template string renders the Python strings into HTML. Okay, this is an HTML. On your Python, you send, hey, whatever this value goes to TMPL, home/TMPL. Then home/TMPL here. In Python code, this is nothing but home underscore TMPL equals, all this is like a string, right? Quote, quote, quote. Within the triple quotes, these are the string. Those strings is assigned to this variable, home TMPL. The string is nothing but HTML code. So goes to that HTML code with the value, user and balance. Then in that HTML code, we are waiting user and balance code. And also URL4, this is a function already given to you, right? already, this is a built-in function. So we say logout goes to logout, right? I said somewhere here, yeah. This is a URL4 is a URL4 Flask routine function. What am I here? Okay, so we have a render template string, then it goes to that. Find out this web page, but web page, this is a web page variables. So this variable holds web page. See here. This is a variable in Python that holds all of this. That is HTML. Login, that also. All of this, that is HTML. Transfer, all of this, that is HTML. And it brings user, balance for Alice, balance for Bob, and login, transfer. This goes to that login, transfer, simulate forged transfer, and logo out. Those are the URL function. So here, function goes to login, then login, and log out, and log out. And transfer, there's a function for transfer. So another one here, simulate forged transfer. If you see this is simulate forged for transfer, these are the simply the comment, right? And there's auto post, this is HTML, nothing but HTML page with a super dangerous threats, vulnerabilities. We have a script, JavaScript there. So it can get the element by ID F. If ID F, then we simply submit. So what kind of ID is? If a form ID is F, then submit it. So within this form, the ID is F. We simply sneaked in that F ID, and that F ID is used here. When it comes to this form, we simply submit it. We don't do anything. What that means is that to user, to Bob, how much? $25. Transfer. That is forged transfer. So when this website is up, then automatically transfer. That is vulnerable, right? Vulnerabilities. This is the end of the files. So go back. I'm going to point out a little bit more. Okay, so go back here. So this is a web page, right? HTML. So on home page, user and balance listed. When you log in, then it says login name and password, and then the text field, and then there's a submit button. Transfer, you can choose who do you want to send. So we have a select options, either Alice or Bob, and then amount, how much. And then there's a text field, amount. Default value is $10, but you can change this. this goes to this URL, home. I mean that the home function is activated. So when you come here, that's a home function, right? Home function. If user is currently available, then render that web page with that Alice and web. Similarly, a login and then get. This is a logout. Yeah, logout user. I believe this is, yeah, now we need to upgrade. But before we do upgrade, I am going to show to you the entire coding list. So that is, I think I need to make this a little bit. Oh, it's not available here. Okay, so we want to do. So this should be run on, let's see, PWD. This under 455, that directory. So which is here. Compare. In that directory, I have many programs available, but the baseline program is app.1. So I want to do copy app1 to app.py, and this app.py, that's nothing but this. So it could be, if I want to explain that to you more closely. Yeah, this is not really, it's the minimum size. How can I? Okay. I want to have a little bit. Okay, that's okay. So in this, I'm going to explain this as a whole, right? Module imported, and an object of class Flask is constructed. From that object, we assign the field name, although this is vulnerable, right? You could do something else. And then another object called the login manager. The object name is a login manager. Then login view is assigned. And we have a dictionary, two dictionaries, users and balance. And the user class created, and the load user. So this function invokes this user, which means it creates an object of a user. In this class, user object is created by having ID value. ID is nothing but username. Username here in this case, if we say Alice, if Alice user ID is in user dictionary, then we put that user. So user's ID is nothing but username there, because I use username as a user ID in this function, which further used by that class definitions. And then I have here the web page for home, another web page for login, another web page for transfer template files, and we have a Python function that can access to slash, which is home page of that address. And then there is the login home page and logout and then transfer. In this transfer, the amount, if amount is greater than 0, then we can raise the exception. If user ID is not in the balance, then unknown recipient, we check the exceptions. Otherwise, we transfer their money, right? The current user's amount, that amount is subtracted. If I say, hey, I want to send $20, that amount needs to be subtracted from the current user balance. And then that same amount needs to be added to the to user, the recipient user. Remember here, plus equal and minus equals. An exception is handled. And then the forged accounts, forged transfer, then we don't do anything. This is really the vulnerabilities, because we have here script automatically, silently processed. Okay, so this is that app.py. So I will do Python 3 app.py and it runs. So web server is running. The web address is currently http://127.0.0.1 : 5000 port number. So I want to copy this and come back here. I want to open this. Okay, enter. So which one first comes out? Of course, home, right? So home is this. This is home. Money bank, step 1, insecure, no CSRF. That needs to be come out. So money bank, step 1, insecure, no CSRF, user anonymous, balance. So here, this guy says balance Alice Bob, and then we can show login. If user is anonymous, then login page. Else, transfer or similarly the forged transfer. Remember here, this is in Jinja 2 language, curly brace and percent sign. This is, in this case, if conditional statements, and else. Okay, so initially, user is anonymous. By default, that is anonymous, right? So user was to run. Here, home user, current user is user. If it is authenticated, otherwise we put anonymous. So currently there is no user. So this user will be nothing but anonymous. So we have here anonymous. Balance of that, and initially login. So if we click login, then we have here, I can say Alice and pass 1, 2, 3 and login. Because that is Alice is known. See here, if it is not anonymous, then else. In else, we have a transfer and simulate forged transfer. Transfer simulated forged transfer, that is shown, and also log out. So if you want to transfer, then from Alice, if you do to Alice, then it has nothing, no transfer, right? See here, transfer here, it says transfer request to post, request to user. That should be to user, not myself, right? In that case, we can transfer. So if you say here, Bob, I want to, because I logged in as Alice, I want to send $10, or initially $1,000 each, right? So I want to send the $10 to Bob and send. Click this, then it says transfer $10 to Bob. If I click home, then I can see the result. So Alice now 990 and Bob 1010. So if I click this, what happens? Automatically, I didn't do anything, but only when that web page appears, then it says a transfer $25 to Bob. That is what here, simulate the forged transfer on this script. That is, this page is automatically submitted. What is that page? That page is here. That page to Bob, we want to send $25 automatically. Don't do anything. So when I see home, see here, further $25 added. This is vulnerable, right? One thing, this is the vulnerable. The other one is, remember that we were talking about session and session token and cookies before we upgraded this. So how can we check the session cookies? How can we see it on this web page? Each web browser has different ways, right? But if you are working on Chrome, then on the left, 3 dots in vertically, then there is a more tools. In more tool, there is a developer tools. Click that. There are many applications, some others, storage, and where there is a cookie, and then this is specific web server cookies. Okay, so if you see here the cookie values, then you see the cookies. These are the cookies. Okay, cookie is automatically generated. And the transactions between browser and the server, web server, see here browser and web server, there's 2 players. Server, once you log in, then server, whenever the page is moved from one page to another page, for example, login page, transfer page, and checking balance pages, and there are as many as web pages available, right? So transferring from one page to another page, the web server does not ask you to enter your login and password. The web server simply check your session cookies. If your session cookie is valid, and also same as the cookie that I give it to you, then trust it, right? Here is yeah, Alice logged in Money Bank. So Alice posted log in to the server. Then server send cookies. This cookie remains. So Alice visit the attacker's page, get the evil page, then this server see that cookies, because whenever it shares it between browser and a web server, cookie is attached to it, right? So unless this web page checks, for example, CSRF protector is assigned, then it simply accepts it, right? Automatically. If there is a CSRF token not available, then it says okay. So we need to check that on your, that's what we are looking at here on this Flask, how we can handle it, right? So this is the cookies. So we see the vulnerabilities. So how can we upgrade it? Okay, so what I want to do, I want to get that app, this, right? We need to do many things that we need to upgrade. All right. So first we have to import some others. Let's say from date time, import time delta, and also import secret. And more from Flask WTF. Remember that is a web tool forms where we can import CSRF protect, and also from Flask WTF.CSRF and import generate CSRF. And then we do a little more here. Cookie hardening. So app dot configure dot update function. There we need to harden For example, session underscore cookie underscore HTTP only equal true, and then session underscore same site, put lex session underscore cookie secure equal false. Permanent session lifetime equal time delta minutes 20 minutes. I would say 10 minutes. Okay. All right. So more of that. Then with another object, the CSRF object is constructed from CSRF protect. SRF having that Flask objects app. Okay, so here is an load user, and we will see another, we'll define another function of that Python, say rotate. Remember that the cookie needs to be rotated, right? So session cookie will be changed. Session clear. Session nonce. Remember the nonce is when it is available, we can use only one time, right? Nonce. Secrets dot token URF safe. Oops. URF safe and 16 bytes. If it is a 16 bytes, then can generate 22, right? Every 3 bytes can generate four characters, 4 bytes. And then here user, and then I want to show the nonce. So in this web page, and there's a paragraph, nonce, and then we have a break, and then I want to have that nonce value, double close for that. And then close that block and close that paragraph. Okay. This is anonymous. If it is known user, then we go for transfer and simulate forged transfer. Okay. And I want to put here log. This is log out. I want to check this log out. Log out is important. So whereas it logs out, then we want to reset the session cookies. Unless otherwise, when one user logged out, the session is still available. So someone catch it and use as if that logged out user. So when user logged out, everything should be cleared. So we set up here form. Again, method needs to be posted so that it will be secure. Add action equals so one of those URL or logout. So it should be close that one, and then that. Input type equal name equal token value equal token. And that should be double quote, close, and close that input. Then we would here button type equals submit button, then log out. And then close form. We don't need this. So log out is in another form. So a little more secure. And this login, we need to have CSRF, right? So here input type equal hidden, name equal CSRF, That is for login. So we entered this. So this is CSRF token can be activated. Therefore, session key can include a CSRF token. So you may be able to see it. See here, this is a session key, the little shorter, right? So when you have this CSRF token is generated, then you will have a longer session key. Of course, because if it is the longer length, more secure. Not only that, but it can be rotated, right? Can be clear that out. And that malicious code, like a simulator forged transfer, not able, no, it's not allowed. That the script is not activated. So we need to put here transfer. In this transfer, I want to copy this nonce here, and this transfer logged. And here home. I want to do a little more here. If nonce not in session, nonce that is generated, if it is not a session already, then the session key nonce needs to be set, because this is a dictionary format. So we create the key sessions from the random key generations, secret.token URL safe. I want to put 16 bytes. And after this user, I want to send that nonce variable for that web page, because remember that we have a web page for the session. Here, for example, in this home, I want to put nonce data to display, so that needs to be sent that way. In login, also when a new user to log in, then we need to rotate the sessions. So put here rotate session. And then here, login and session dot permanent, that field. That needs to be true. As far as this, the login, the user, to that each separate user, session key is available. So when you go in, if you are, then your session is recognized. And then here, log out, app.logout, app.get logout. This needs to be changed to post. Remember that that is vulnerable. So when you log out, if you log out, that needs to be cleared. So when you log out, rotate session also needs to be done. Okay, and so route transfer. We want to keep the transfer. And then simulate forged, we keep this get, so that is vulnerable. Anyway, we need to make this vulnerable, right? Although this is vulnerable, we want to see it goes well. And this transfer here, the render underscore transfer strings, this transfer TMPL user is according to user ID and message, and then here's a nonce because that transfer TMPL, I want to put here nonce, right? So that needs to be sent out. So here nonce equals session dot get and nonce. Okay, so we've done pretty much upgrade, and I want to save this. Okay, that is saved. I want to rerun that. Oh, what happens? Syntax error. Session.get. See, 100, line 100. Line 100. Nonce. I need to end. I have here the comma. Should be app, not SPP. Line 12. Okay, here that should be app. Oh, it goes well. So if I want to do this here, unexpected, where exception. It's not really friendlier. Jinja 2. Python is okay, but where? Maybe HTML. I want to check. HTML, this is I entered home. Somewhere here. Method equal post. Let's see if it is small. Post action. Oh, it's closed already. Open and open. Two open curly braces and close up curly braces. Probably that one. Let me check out this. And login temple. Then we have this input type hidden, name CSRF underscore token value. Okay, that's fine. And transfer to when to put here CSRF for project. This is not really the issue, right? This is a simply string. And nonce that is there. And input transfer to ampere. I think I need to bring this also here. Transfer TLPL. We have a form here. I want to have that one here. Okay, probably, hopefully this works. Then I will interrupt that to stop and then rerun. I want to have this rerun. Still not work. Oh, there is. Oh, it gives me the error messages, which is good. Okay, call here. Call. This guy comes from. Okay, this 97. This 97. Line 12. Line 12. Ah, this should be curly brace, I think. I think this is simply the function. Okay. Let me check the spell. Session cookie HTTP only equal true. Session cookie same site collects. Session cookie secure false. Permanent session lifetime equal time delta minutes 10. Okay, let me try again. All right, looks okay. Oh, good. So it gives me the nonce, right? So if I do login and Alice and pass 1, 2, 3, I log in and I want to transfer $10 to Bob. Okay. So when I see this, then $10 moved to that. This is a demo. Simulate forged transfer. Remember that in this case. Oh, we need to change this to. I need to change this to here. Step 2 and secure. I would say secure and CSRF. I want to change it to redo rather than this. I want to redo. Okay, step 2, secure series, which is good. I want to log out and do it again. Login and Alice, pass 1, 2, 3. Login, and I want to transfer the money to Bob, $10. Send, transfer the 10 to Bob, check at 99. To see if forged transfer is possible, when I click this, it prohibited, right? I didn't change anything for that here, right? Yeah. No forged TMPL. Yeah, this is transfer once, but I didn't change here. Transfer anything at all. It remains the same as before, but that is protected. Come back here. I want to show you now. Remember, this is the cookie. I want to check the cookies here again. And come back here, more tools and developer tools. And when I see the cookies, see this is longer, right? 1, 2, 3, 4, 4 lines. Previously 3 lines. So CSRF tokens is attached to the session tokens. It is secure, right? Token wise, session token wise, it's secure because of that CSRF. Here in this case, if you want to forged transfer, then it is prohibited, right? So this is a 2 demo. And next one that I want to do, your homework assignments. I'll give you the demo of your homework assignments. Okay. So I already tested it. So app7.homework2 app.py, and I want to run that app, and I will show you here in another. When I run this, they're most likely similar, but it checks, for example, the user login, Jaeyun, I want to log in how many times. I want to do, for example, JY, it's a different user, login. I want to do Alice, but not the same password, but another password, so it's invalid. And I want to do Jayun and another login. I want to do Jayun and another password, login. And I want to do Jayun and another password, login. Do similar and more. I believe one more. Then that is the maximum settings. Whatever the number that you set, then it says here, the account to Jayun locked. Try again in 173 seconds. So you can check how many seconds that you want to do, right? You can provide that. So if it lasts that much, then you can re-log in. So that type of things can be implemented. So a little bit of added to the upgraded versions. That is the homework assignments. Okay. I know this takes time. I'll give you enough time, maybe 2 weeks, so that you can handle it. All right. I believe that is it for today.